What's going on, guys? Let's do this problem right here. The first question is asking a wire of resistivity rho must be, so this is must right here, must replaced in a circuit by a wire of the same material but 4 times as long. So if it's same material, rho is going to remain same, and however the resistance of the new wire is to be the same as the resistance of the original wire. The diameter of the new wire must be what? So that's the question that's asking. So they are saying resistivity is going to be same because same material, and resistance also going to be same. And let's see how we can find the new diameter that matches. So they are increasing the length to 4 times. So let's see what happens right here. So I'm beginning right here, the first question. So let's write the equation for the original, like the previous case. So when we don't change anything, right? So we know that the equation for resistance is given by rho times length over area. So whenever we have a wire that's a cylindrical shape, right? So the cross sectional area is going to be simple. So the area is here. The area is going to be 5r square or 5d square by 4 because r is d by 2. If you square that one, you will get d square by 4. So that's how we got this relationship. So we can rewrite this one as rho L over 5d square over 4. I can bring the 4 to the top, so this is going to be 4 rho L over 5. Let's say this is d1 square because we are trying to find the new diameter, right? So this is when we don't change anything. So when we increase the length 4 times, right? Let's see what's going to happen when we increase the length 4 times. So if I increase length, r is equal to, so if I increase length 4 times, this is going to be 4 times 4, we are going to have 16 rho L over 5 d2 square, right? So the question is asking what is the new diameter we have to maintain the same resistance. So all we have to do is just equate this one, right? If we have to maintain the resistance, the resistance is going to be equal. So we can, if we equal this one, we can find the new diameter. So let's equate both of these and see what we get, right? So here we are going to have 4 rho L over 5 d1 square. That's going to be equal to 16 rho L divided by 5 d2 square, right? So let's cancel everything we can cancel. If you look at this one, rho L cancels each other, and 5 cancels, and 4 and 16 can be cancelled and rewritten as 1 4, right? Because 4 times 4 is 16, so 1 times 1 4 ratio. So let's rearrange this equation and see what we get for d2. d2 is the equation that we're trying to find. D2 is the answer that we're trying to find. So here we are going to have d2 square is equal to 4d1 square. So the new diameter is going to be, if you square the root of this one, this is going to be 2d1. So the new diameter is going to be 2d1. So let's look at the answers right here. So the answers are, the first answer is 4 times the diameter of the original wire. It's not 4 times, it's 2 times. So it's wrong. Half time diameter of the original wire, that's also wrong. 1/4 of the diameter of the original wire, wrong. The same after the diameter, wrong. 2 times the diameter of the original wire. So this is the right answer. So the answer for the first question is this one. Let's look at the second question. So let's separate this one first. So the second question is asking the temperature of coefficient of resistivity for copper is 0.0068 degrees Celsius per degrees per Celsius, and here there's per degree Celsius, right? -1 means it's like divided. So if a copper wire has a resistance of 104 ohm at 20 degrees Celsius, what is the resistance at 80 degrees Celsius, right? So first of all, if we have this temperature difference and this coefficient of resistivity, we can only relate one equation, that is R is equal to R naught 1 plus alpha delta T, right? So this is going to be the equation. So here we are trying to find the R. So that's what the question is. What is the copper has the resistance of this. What is the resistance at 80 degrees Celsius? So we are trying to find this final resistance. So this is initial, this is final. So let's see what we get. R naught that's provided 104 and 1 plus alpha, that is coefficient of resistivity, that's 0.0068. 0068. Delta t is going to be final minus initial, right? So final is going to be 80 minus initial, that is 20. So 20 minus 80, 80 minus 20. So that's going to give us 60. And let's calculate this value. This is going to be, so we are going to have 104 right here, and inside the bracket we are going to have 1 plus 0.00068 multiplied by 60, and let's calculate this one. If you calculate this one, you will get 104 times 1 plus, if you multiply this one, that's going to give you 0.408, and if you add them together, that's going to give you 104 times 1.408, and if you multiply them together, that's going to give you 146.4 ohm, and that's going to be the final answer. And that's how we do these kind of problems. And let's round these ones to make sure this is the final answer, right? And that's how we do it. I hope you guys find this video helpful. See you next time.